Oh, hello everyone. I'm Pavlos. Can you see my slides here?
Yes.
Okay, great. So, hello, I'm Pavlos. I'm a director and technical lead at the Measurement Lab, and I'm happy to be here. For me, it's my first OMG event that I participate. And I'm happy to share some information and some updates from MLab, from Measurement Lab, and see how we can contribute to the efforts of our community towards a more free internet, better internet. So the topics we are going to cover today in this presentation. First, we would like to give you a brief introduction to MLab's platform and data, so we get the basics, even for people that are not that familiar. On top of that, we will see how this platform and data can help your efforts and what we do with this platform and data. And as a use case, we'll present also how Giga from UNICEF uses MLab's platform and measurements to monitor school connectivity worldwide. Then we will present a set of updates on the data, on the platform, and on the analysis you can do with the data. The first, it's about a new data set that is published, that has been recently published through MLab. Then it's about the evolution of our platform and the new type of servers we are building. And third, it's about the Internet Quality Barometer, a new framework on analyzing data in order to assess and quantify internet quality. So let's start with the basics, introduction to MLab. So who we are. MLab is an open source project that was funded in 2009, and now it operates as a fiscally sponsored project under the Code for Science and Society organization. What we do, it's we measure the internet, we save the data from the measurements, and we publish them and make it universally accessible and useful for everyone. And how we do that? Let's start from our platform. So in the internet, there are a lot of users, people who use their computers, mobile phones, laptops, etc., that they connect to different services. They are emails, the video streaming services, or websites. All these services are served by servers. And the quality of the internet performance depends on the network that it's between the users and the servers. And as Measurement Lab want to measure the internet performance, so what we do is we have our own servers where users can connect and then they can measure the internet performance, the performance of the network between them and the servers. Our servers are located in different places all over the world. Usually, they are located in interconnects, in interconnection points where different networks connect to each other, different ISPs. And we have also servers in data centers and cloud VMs. There is a mix of servers there. And here, this map shows the picture of is a picture of where our servers are and how many they are. In totally, we have more than 500 servers globally. You can find out them at this link. And they are deployed in more than 40 countries and more than 100 metros. And they are served through more than 50 trusted providers. So what do these servers do? These servers do the actual measurements. They measure the internet. And when we say measurements, the main set of measurements we do, the main experiment, as we call it, is the NDT experiment, the Network Diagnostic Tool, which is an experiment that measures the connection speed of a user that does the measurement. So it measures the download and upload throughput, latency, loss rate, etc. However, there is a set of other experiments that have been developed by collaborators and they run on our servers, and we can do measurements also for these experiments. And these measurements can be about video streaming and the DAS. It's the DAS experiment, or they can be used for reverse trace route that relates to internet routing or to a set of different applications. It's the way he experiments. So when users run some tests, in fact, they connect to our servers, and our servers run these experiments. And when the experiment is done, there are some data about the internet speed and whatever the user has asked. These data are first communicated to the user who does the experiment, and second, they are published in a public database in a BigQuery where they are accessible by everyone, by everyone. So this is what the servers do. But what about the users? What do we mean? How can I run a measurement and test my speed using MLab? So the main source of the majority of users use our platform through Google Search. So Google Search has integrated tests from our platform. So if in several places in the world, if a user goes in Google Search and asks how fast is my internet or internet speed test, Google returns a screen like that where you can see a blue button that says run speed test. And if you click this blue button, the user is connected to our servers and an experiment is run. However, this is not the only way to run an experiment with MLab. We also have our own web application where you can go through your browser to this link and run a test and get your results directly. And also, we provide a set of client software, some software that some third-party organizations can use and integrate it in their websites, so their users can check through their websites about can run measurements and check their speed. A notable example is Airbnb, and another example is Giga and UNICEF, for which we will talk in the next section. The last, but not least way, where someone can run measurements is the Murakami software, which is a software that anyone can download. It's publicly accessible through our GitHub, and they install it in their computer or other devices and run automated measurements from any computer. So if you can download this to your computer, or if you are collaborating with a set of users, you can share it with them and everyone installs it in their computer. Or if you have your own fleet of devices, computers or Raspberry Pis, I mean, the requirements are really minimum, you can run automated measurements from all these devices. And doing that, and depending on what are your resources, how many users, how many devices you can find, and where you put them, and how frequently you run these experiments, you can design measurement studies and monitor internet connectivity and performance with any regional focus you want. You can install these software in devices in a specific country or city or region in any detail by choosing how many users you will use, and you can scale it as much as you like. Again, the data of these measurements will become publicly available through our public database, which is hosted in Google's BigQuery, and it's really easy to access the data. So to access the data of your measurements and everyone else's measurements since 2009, you only have to do two steps. The first one is to sign up to our Discuss list. So you follow this link. There is a button that says sign up, and then we review your request and you are signed up. It's that easy. And the second step is to go to the BigQuery. This is the link here, and directly query the data. How to query the data? We have several tutorials and material content in our website where you can find the instructions how to do that, as well as detailed schemas for the data sets so that you know exactly what you want to query. And the only knowledge you need to know is SQL, because it's like SQL queries. And if you are more familiar with Python, if you are a data analyst and you don't like that much BigQuery, we have some examples that we have incorporated queries to BigQuery through collabs, and you can follow these links that will be made available later. So to give you a quick view of how BigQuery looks like, it is like that. You can open it with your browser. You can find the Measurement Lab project here on your left, and then you can open a tab and query. Queries, as I said, they are basic SQL queries, and here are a couple of examples. So on the example on the left, you request from the table that has the entity data, the speed test data, you request the test time and the throughput from all experiments that are between a date. And this is important because you cannot request everything because there are too many data. You have to define a range and then filter probably by a country or whatever else you want. So here we get all the data from users in Uganda within a period of a month. And of course, you can add more data in your responses and filter with city or ASN or anything else you want. Now, let's move to the second part and see how our platform has been useful to Giga and UNICEF. And we will highlight this use case, which we consider quite notable and has quite a lot of impact. So Giga is an initiative that is launched by UNICEF and ITU in 2019, and with a mission to connect every school to the internet and every young person to information, opportunity, and choice. So the main efforts of Giga is the development of Gigameter, which is a desktop application that is installed in computers that are located in schools all over the world and allows school administrators to monitor their internet quality, their internet performance and connectivity. Right now, it is deployed in more than 10,000 schools in 27 countries. And in total, they have done more than 1.5 million measurements. All these measurements are presented through the Giga Maps, which is a web interface that Giga publishes the data. And here you can see the world map and you can see the dots that correspond to school locations. Blue dots correspond to schools, but they don't have measurements. Green and red dots correspond to schools that they do have measurements. And the measurements that are presented here, they are live data, so it's a live map that shows real-time connectivity. So Gigameter, the application that's behind that, it's a desktop application for Windows that uses minimal data to automatically perform 4 daily tests per school. And the tests are towards MLab servers. So in fact, they use the NDT experiment we discussed before. When these tests are run, they are fed to the maps of Giga, but also they are made available in our public database in a BigQuery. And this is important because in this way, Giga contributes a very interesting data set to MLab's data. And these data set are these measurements from the schools, and it's important because they are regular periodic tests which help you monitor internet performance over time from specific locations. They contribute a lot of data, 1.5 million measurements since 2024. And the important thing is that they contribute data from schools and locations in countries that are usually underrepresented regions. So countries in Africa, Central America, etc. And also the data are quite diverse, the locations are quite diverse, and this we can see since the data, the measurements are against the MLab servers in more than 70 different metros all over the world. Now, let's move to the updates and go with the first update, which is about a new dataset that is published through MLab. It's the IP route survey, or IPRS. And in fact, this is a dataset that is collected by the Dioptra group in the Sorbonne University in France, and specifically the Lib 6. lab. It contains trace route measurements, periodic trace route measurements, and its goal is to monitor the IP level routing across the internet, to continuously monitor the IP level routing. Again, these data are made available in a BigQuery, and you can find more information on how to access them in this link. So more specifically, what are these data are about? These data are from measurements, from regular measurements, trace route measurements from 10 different vantage points to every routable IPv4 prefix. So we have 10 vantage points, and each of them does trace routes to every routable IPv4 prefix. And we collect, Dioptra group collects the data and we publish it. With this data, they are quite rich data, and there are different use cases you can think of. Here we have only some examples that can be used for inspiration, but if you have any other ideas how to leverage this data, let us know, and we will be happy to collaborate also on that. So these use cases, the main reason of using this data could be to get a broader picture of internet routes and discover new routes, or to correlate this data with some MLab measurements at a given time, for example, to examine some anomalies. So if some internet performance measurements relate to some routing events or to a specific area or to a broader phenomenon, or this data can be used to complement and be or compared with BGP data, other data, not MLabs data, since they offer the similar view but from different vantage points and in a more fine-grained way. So with that, you can see significant or unusual routing changes. Okay, next update, apart from data, it's about our platform. And we would like to talk about the host managed deployment, which is the new type of servers that MLab has started hosting and integrating in their platform. As we have seen before, these are the MLab servers all over the world. However, these servers are not of the same type. Not all of these servers are made equal. So historically, MLab started with some physical servers deployed in different networks all over the world, which we controlled. So this category is the MLab managed servers. Then we added also virtual servers, again, under the control of MLab. Now, now recently, we have introduced the host managed servers, which are the same type of servers, virtual and physical, and the difference is that these servers are managed by the host, by the network who deploys them. And specifically what they are a single server that runs software from MLab that anyone can download from our GitHub and is managed by the host organization. Why we did that? We did that to make it easier for people to contribute servers because they don't have to give us direct access, and to find contributors of different types. How to do that? It's quite easy. So the first step, if you're interested, is to complete our infrastructure contribution form, and then we contact you and we register you to our platform. We give you the software, you install the software in your server, and then the server is up and running, and anyone can run measurements against your server. These servers has light requirements. We require one IPv4 or and IPv6 address, minimum 1 gigabps uplink. Probably it's better like 10 gigabps uplink, and 4 GB of RAM and 4 Intel cores. We have started and we have deployed several of these servers in collaboration with some initial early adopters. Now, why we did that? There are two main reasons. And the first of these reasons is seen in that map. In particular, it is seen in these areas, where we can see that MLab does not have servers everywhere in the world or with the same density. So there are some regions that are underrepresented, and here there are the examples of Middle East and North Africa. So what we wanted to do, and something that is fully aligned with our mission, which is to measure the internet openly, is we wanted to have a footprint, to have a larger geographical footprint, to have servers in as many places and as many diverse places in the world as we can, because that will improve measurements, improve the data in the measurements, and also give access to more people to run more accurate measurements. So this is the first reason that by deploying these self-host managed servers, we have the opportunity to deploy more servers to diversify our measurements and our data. And the second reason is that with this way, we also diversify the platform who operates the servers and the costs. We don't rely only on a few organizations that partner with us and host our servers. Now, the current status, we are still in the experimental deployment, but we soon, and I will not define what is soon, we'll soon going to scale it out to reach out to more people. We have more than 40 operating servers. Most of them are in a collaborator network in Brazil. It's the research network in Brazil that hosts 27 servers. And these servers currently support only ADT experiments, but it is part of our plans to support also the other experiments in our platform. Our next immediate steps is to make the program generally available to the public and ask as many people as we can to deploy their servers, and make the data publicly available in BigQuery. And this is something that will happen soon, so stay tuned with our announcements about making the current data available in BigQuery. And now the final part of this presentation, it's an update about an analysis that can be used on measurement labs data, but also on other types of data. And it's about the Internet Quality Barometer, which is a framework, and that was developed within a project that was funded by the Internet Society Foundation. It was a 16-month project. The duration was 16 months. And the goal was to redefine internet quality beyond speed. So today, when we talk about internet quality, we mostly have in mind the speed test that you can run, which is what we also do in a measurement lab. However, speed and bandwidth, it's not always what the users care about, and it's not always the most representative way to talk about internet quality. Internet quality depends a lot on the use cases. So, for example, if you are a user that you are browsing the web, then the main metric you need the main metric that it's important for you, it's latency. If you are an online gamer, it's both latency and upload throughput. Or if you're doing some online backup, then you don't care a lot about latency, but you care mostly about download and upload throughput. So with these examples, we can see that for different use cases, internet quality is defined in a different way. And this is how we got inspired about the IQB framework. So we said, okay, there are different use cases. If we want to improve the quality of the internet, or at least monitor it, what exactly should we monitor? What metrics should we monitor, and how do we quantify that? And if there are some people that want to take decisions, some decision makers, and about improving the internet or anything else, what metrics should they follow? And this is what the IQB framework aims to answer. So the IQB framework, its goal is to calculate a score, the IQB score, which in fact it's a composite index that characterizes the internet quality. And this score takes value from 0, which means low quality, to 1, which is high quality. How to calculate that? We need to take into account, as we said, the multiple use cases of different users, video streaming, web browsing, etc. You can define them on your own. We have already done some selection, but the framework is quite flexible. You can add and remove use cases. Each of these use cases depend on some network requirements like throughput, latency, etc. And they depend on these network requirements in different ways. So this is something that the IQB framework takes into account. And for these network requirements, in order to be able to monitor them, we need tests, we need some measurements. MLab has the measurements from the entity test. However, there are also other data sources which you can use and combine with MLab's data in order to better understand, better characterize the network requirements. And this can be, for example, measurements from Ookla or Cloudflare. The IQB framework offers a way to combine all this data to calculate quality thresholds for network requirements, and then combine network requirements, map network requirements to use cases, and then map use cases to the IQB score. So, for example, here we can see that the IQB score is affected by different use cases, and each use case depends on different network requirements. So, for example, streaming video depends on download throughput, upload throughput, latency, and packet loss. And the numbers here indicate what's the importance of its network requirement for the specific use case. How we ended up to these numbers and these quality thresholds is we asked help from experts and stakeholders from academia, industry, and policy making. And we have engaged more than 60 experts through interviews and workshops. With them, we worked together. And first, we defined network requirement thresholds, what is considered minimum quality or high quality for different use cases and for different network requirements. And also, we defined what is the importance of each network requirement to each use case. So, bringing all these things together, we are able to calculate an IQB score, and we have built a framework that shifts the discussion from speed tests to a more representative score for internet quality. And in fact, this was the main goal of IQB, because shifting the conversation can help decision makers make sense of the data and take decisions. Also, it can help users to understand about their internet quality and what it means for themselves. And also, it can promote and give new ideas about how to combine existing data sets, because there are many data sources today and there is a lot of information there, and combining them, it can give us better results. This is something that is not possible now. I mean, more of these data are separately, individually analyzed. And also, it can give some inspiration about some more advanced measurement techniques. And the next steps for IQB, the first step is that we are going to publish the IQB design report, maybe this week or next week. We will let you know, so stay tuned on our social media and on our discussed list. And the next step will be to create the IQB tool, so this framework, to make it an actual tool, a web application. And starting using that, then we can assess the findings of this first iteration. And if we need, we can refine all the weights of different use cases and thresholds, and or develop new measurement methods or new methods for combining data. So if you are interested in these efforts, reach out to us, and we can see how we can collaborate. And since we are here, a community about internet freedom, an idea would be to follow a similar methodology, a similar framework, and create the Internet Freedom Barometer. So in fact, combine different data sets, the data sets we have, all of us have, in order to calculate an IFB, Internet Freedom Barometer score, for each country, for each region, or whatever. This is very early idea. I just put it there for a brainstorm. And with that, I would like to thank you and answer to any questions you may have.
Great. Thank you so much for that great presentation. I can now read some questions from the Q&A. So first, what is the difference between Uniprobe and Murakami?
I don't know. So maybe I can, someone from the Uni team can help me in that. I know about Murakami, but I don't know the difference with Unipro. So is there anyone from Uni that knows and would like to jump in that?
Yeah, I'm happy to jump in. Thank you so much, Pavlos, and thanks for the question. I think the TLDR is basically that Uniprobe was integrated into Murakami back in 2021, which we're very excited about because that helped boost Uni measurement coverage because users of Murakami were also contributing Uniprobe measurements in the process. However, to be honest, I'm not sure what the current state of the integration is. And so generally speaking, if someone is more keen on running Uniprobe, I'd suggest that they use Uniprobe directly because it has all the latest features and experiments. And I'm not sure if the version of Uniprobe that is currently Murakami, I'm not sure how frequently that's updated. So in summary, yeah, and I see my colleague Arturo has also replied in the chat.
Okay, thanks, Maria.
Great. So the next question is on, I guess, websites of lots of organizations in developing countries are often based in Europe or the USA. How does such presence in foreign countries affect measurement of internet service quality, including IPRS?
Okay. Uh, so that's, I'm not sure uh, how to start answering this question. So there are two things. So if websites if we take as granted that websites of most organizations of development countries are based in Europe or USA, then for us that our servers are in Europe or in USA, when you connect to our servers, you would expect to see a similar performance as you would see connecting to these websites. This is one part of the question, but I would like to highlight something else. So, if we don't have a server, a measurement lab server in a country, when a user from this country wants to do a speed test with measurement lab, he or she will connect to the server that is the closer to him in distance, so the closest geographically server. So if we don't have a server in the country, then it connects the server to a different country. And this affects the results because there is more internet between the user and our server. And this is also one of the reasons that we want to add this new type of servers, because this will give us the opportunity to have more servers in more countries. So we have more accurate results because the servers will be closer to the users. Last, it's about the IPRS data, the new data set that it's being published. So the IPRS data set is not, the measurements are not done by our own servers. They are done by Dioptra's group servers. There are 10 servers, and they do experiments and they run trace routes over all IPv4 prefixes. And they publish the data through MLab's public database in BigQuery. So it doesn't have to do with our platform.
Thank you. So our next question is, does IQB incorporate buffer bloat specifically, or is considered a part of latency? In my experience, buffer bloat can have a huge impact on perceived quality, even on connections with low unloaded latency.
Okay, that's an interesting question. So, IQB incorporates latency. And this is because in the IQB, the first step of IQB is to take data from public measurements, from measurements like MLab, Cloudflare, Ookla, etc. And the data, the metrics that are there, it's a latency. However, if there are any ideas how to integrate results that are directly related to buffer bloat, or they can be indicators for that, then the IQB framework, it's quite flexible, so we could incorporate it, and we can have different variations of the framework.
Awesome, thanks. And then the last question is about the presence of school servers in West Africa and whether you have those in that region.
Okay, so this is our map. We can see that West Africa is underrepresented in our platform. So yeah, we would be happy, really happy to discuss about that.
Awesome, and that was.
By the way,
sorry.
Melissa has put in the chat some information about the host managed deployment, so you can check also for the interested the participants that are interested in that, they can check also that link.
Great, and that is it for the questions in the Q&A. So if anyone has any more, feel free to ask them now. All right, well, thank you, Pavlos, for that awesome presentation.
Thank you.